Hello everyone, I am Subhrajit Asst, Assistant Professor in Narsimha Engineering College. So I welcome to all in this session where I am going to discuss about the uh, thermocouple, right? Thermocouple is my today topic where I'll start the discussion from the basic principle to its application level. So before starting the construction working principle of thermocouple, how it is working, let me tell you some basic principle on which the thermocouple concept is working actually, and who discovered this beautiful concept, who is the great personality. Let us have introduction with that personality first, right? Who is that person means if you look at this picture, he is the great personality who gave some basic principle on which the thermocouple is working. Sir, what is the name of this person? The name of this person is Thomas John Seebeck. Right. The name of this person. Really, the concept what he gave, what he contributed to the world of science, really it is helpful to create a very interesting temperature measuring instrument which is widely used all over the industry area, aerospace area, home appliances, a lot of space, a lot of place where you can use that temperature measuring instrument which is working on the principle of given by this person only. What is that principle? I will tell you the details. What he told after the several experiments, several observations he did with the different metals, one conclusion he given. What is that conclusion means? Suppose we have two dissimilar metals, metal A, right? This is metal A, and another metal is, suppose you have metal B, like this. Two metals are there. He told you join the two metals at two end points. Here one join, you do here one join. We can say a joint, right? Produce two joint or two junction. You produce two junction, more appropriate word for this topic, right? Two junction you produce by joining the two metallic wires, right? When you joined, you keep one junction at more temperature region or higher temperature region or hot junction, we can say hot junction, and another joint or another junction you keep at cold place, right? Cold place, generally this is taken as 0 degrees Celsius, right? Just like the water freezing point, right? 0 degrees Celsius. So if there is a temperature difference between the two junctions, then automatically voltage will be produced in this circuit. Okay, voltage will be produced in the circuit. If it is a voltmeter, right? If it is a voltmeter, then this voltmeter will show some reading of voltage produced by doing this kind of connections, right? Very interesting, very interesting, right? The This concept is given by this person's based on his name. He gave this principle as Seebeck effect, right? Seebeck effect. This principle, sir. What is the principle, sir? You take any two dissimilar metal, join at two end, construct two junctions. You keep one junction at a hot area, another junction at a cold area, generally freezing point of water 0 degrees Celsius. Then automatically some voltage will be flow in that circuit or in the through this metal connections or through this arrangement, we can say, right? Sir, can we take any kind of materials for this one? Yes. Any kind of materials if you take, no doubt every metals, suppose I will take any kind of materials. For every metals, if I will do this kind of connection, this kind of joint, and I will keep one end at hot junction, another end at cold junction, no doubt voltage will be produced. Voltage will be produced there. But that voltage is very, 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 very less. Very, 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 very less, which may not be sensed by a voltmeter, which may not be sensed by a voltmeter, right? Voltmeter also will fails to measure that minimum amount of voltage, right? So any metal you took from the universe and you do that kind of arrangement, voltage will be produced, but that voltage quantity, the amount of voltage may be 0.0000000001 volt, which is very, 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 very less. And this kind of measurement may not be identified by a normal voltmeter, right? We should choose that kind of material which is very much sensitive to temperature change, and at least a voltage should be produced which is be identified by the voltmeter, which should be identified by the voltmeter. That kind of material we should choose. Sir, is that kind of material is available? Yes, obviously available. CBAC also given the list of the materials, what material combination will be produced a sufficient quantity of voltage so that it can be used to measure a temperatures. It can be used to convert into a suitable temperature scale for measurement of temperatures. That kind of material list is available. I will show you later. First, you understand what is the principle of this Seebeck effect, right? Very simple principles. Just I told us 2-3 times already told. This is the principle. Sir, metal A is there, metal B is there. You connect and form two junction. Keep at one hot junction, one cold junction. Generally, the 0 degree Celsius, right? Reference junction also we can say this one. Freezing point of water. Then what happened? The change in voltage will be produced. Some voltage difference will be produced in the circuit. If you will attach any voltage measuring instruments, it will be reflect some reading here. This effect is called Seebeck effect. Okay, Seebeck effect. So this beautiful concept later utilized to construct a temperature measuring instrument. Construct a temperature measuring instrument. Okay, what is that instrument means? The instrument name is thermocouple, right? The name itself indicating that couple something double. So two metals, double metals, dissimilar metals we are using here for this thermocouple constructions. What are the metals are here? See, list of metals are available here. In details, I will tell later, right? So copper, tungsten, nickel, iron, platinum, rhodium, all these metals are available in the universe. We can take for construction of thermocouples, right? But the percentage of platinum and rhodium is very, very less. The availability percentage is rare. We can say rare. That means 0.0000035 per million, 1 million of earth. Okay. 1 million part of earth. That much quantity it is available, which is a very less quantity. It is more costly. This two metal is more costly. So for frequent construction of thermocouple or more mass production of thermocouple, we are not using this two metal. Some for specific purpose we are using this metal because rare. If you use this metal, the cost of the thermocouple will be increased. It will be high because this materials itself high cost, right? So what are the other metals are used for this? Here are their list of metals, right? We can use nickel, chromium, constant irons, right? Like this, copper also we can use for the measurement, for the construction of this thermocouple, because it is widely available in the natures, right? More quantity is available in the natures. Okay. So now coming to the constructions, or where it will be used or how it is constructed. There is simple construction. I hope you understood the principle of this thermocouple on which it is working. That is Seebeck principle, Seebeck effect principle, right? So here, observe this diagram. Clearly, it is saying what is that? Sir, these are the two metals. One is red color here. Okay, metal A, suppose this is metal B, right? And here the junction, hot junctions. Okay, and we giving some heat by burning some candle here or any burner, gas burner you can burn here. Just for your understanding, this diagram I have collected from the internet, right? And this is the another junctions which is kept at 0 degrees Celsius, right? So how to make it 0 degrees Celsius? You can use some ice bath continuously to this junction so that it can be maintained at 0 degrees Celsius, which is called as reference junction also. Reference junction, right? Then through this copper lead, copper wire, we connected a voltmeter, right? So this is a simple constructions of the thermocouple. Sir, how it is working? Just I told it is working on the principle of Seebeck effect. What will be happen, sir? Very simple. Two cases we are going to consider. First is normal consider normal conditions. First is normal conditions. That means when this burner is not available. When this burner is not available, right? That means the measuring instrument is kept in the surrounding in the open atmosphere at normal condition, normal atmospheric temperature it is facing right now. In that case, suppose the temperature is 30 degree and here cold junction reference temperature, which is the freezing point of water, I know that temperature is what? 0 degrees Celsius. Then what is the change in temperature, sir? Change in temperature is 30 minus 0 is how much? 30 degrees Celsius. This is a change in temperature. Maybe for this change in temperature, voltmeter will show the reading here. Some reading. You take that reading as a reference reading or starting reading. Reference reading. 1 volt, 2 volt, whatever it may be. It is showing. You take it as a starting reading or reference reading. Now, you expose this heating source near to the hot junction. That means now it is comes in contact with the hot junctions, right? If it is comes in contact with hot junction, then temperature here slowly increase. Let it become 30 degree to 70 degree. It convert 30 degree to 70 degree. If it's 70 degree, now the temperature difference become, and still here it is 0 degrees Celsius, the reference junction temperature. Now temperature changes 70 minus 0, how much? 70. Earlier it was 30, now it becomes 70. How much variation done, sir? 40 degrees Celsius variation done. If 40 degrees Celsius variation done, then this voltmeter is going to deflect from one position to another position, right? One position to another positions. So how much voltage changes here del V is proportional to del T, right? Is proportional to del T. If the temperature changes will be rise, then voltage changes also rise here. So beautiful relation, correlation between the temperature and voltage here. It is observed by the Seebeck, right? So once I calculate this del V by this voltmeter, I can convert this voltage, change in voltage to how much temperature by considering a suitable calibrated temperature scale. Calibrated temperature scale. Right? Suitable calibrated temperature scale. Okay, now what is the meaning of this suitable calibrated temperature scale? Many times I told this one, sir, what is the meaning, sir? Very simple. I will tell once again what is the meaning of this calibrated test. Suppose, sir, suppose my voltmeter reading is 2 volt, 2 volt. That time temperature is suppose 30 degree, right? 30 degree. Now when the voltmeter temperature, suppose temperature become 40 degree, now voltmeter reading is on 4 volt. Now temperature becomes 60 degree. Now voltmeter reading becomes 6 volt. That means for every 10 degree rise temperature, how much voltage is changing, sir? 2 volt. 2 volt voltage is changing. For 1 degree temperature rise, sir, 2 by 10 volt. Suppose my voltage is showing 35 volt. Then how much is the temperature at that time? Very simple, sir. I can calculate that time. If 35 volt is swing, then 1 volt become 10 by 2 into 35. That means 2 into 10, 35 into 5. This is 2 5, right? How much temperature is that? 175 degrees Celsius temperature. This is a suitable calibrated scale. In this way, we can construct for temperature measurements, right? I hope this construction and working of this thermocouple is very much clear to all of you. For better clarity, you may refer some online platform also like this, some 3D imaginations figure you can get, animation video also you can get from this YouTube also. You can check that one, no problem at all. Now let us coming to the merit and demerit of this thermocouple. Sir, what is the merit and demerit here? First, I will list out the merit. Merit, what are the merits, sir? By this using the thermocouple, we can measure negative temperature to positive temperatures, right? Positive temperatures. Negative temperature minus almost 200 degrees Celsius to positive temperature 27 degrees, 2700 degrees Celsius. Can measure. It is a very huge range of temperature we can use measure by this thermocouple, right? Okay. What is the second? By using some suitable materials, its cost is less. Cost is okay. Cost is less, right? It can be very rigid in construction or robust design, we can say, right? Robust in design, very rigid in constructions, right? Robust in design. Rigid means very not so weak, it is very strong. The design is very strong, like this. And what is the next advantages, sir? Next advantage is what? It is giving more accurate result. Accurate result, right? More accurate result comparison to mechanical type instruments, right? Temperature measurement range is huge, cost is less, very rigid design or robust in design or strong in the constructions, more accurate result also we can get, like this. Several merits you can list it out. Sir, what is the demerits, sir? Demerits, very less number of demerits are there. What is the demerits, sir? Sir, if I want to measure above 2700 degrees Celsius, then sometimes the instrument will fails to measure. Okay, above fails to measure. Okay, fails to measures. And here one more important thing for in the merit I will tell. It is used for continuous monitoring purpose. Continuous monitoring purpose, like in the medical sectors, pharma industries, okay, manufacturing industries, where continuous temperature monitoring should be required. So in that case also we can use this one. But the glass tube thermometers, bimetallic strip, these are not used for continuous monitoring purpose, right? Because their response is less, right? Here accuracy issue will come. Accuracy issue will come after a certain period. After accuracy issue will come after certain period of use. Okay, certain period of use. Sensitivity decreases. Sensitivity decreases slowly. It decreases. Like these, several disadvantages also we can list it out, right? So merits and demerits, disadvantages. Now coming to the applications, where we can use for the applications, right? Now this is a picture I collected where some I mean composite material is manufacturing. Composite materials. Composite materials manufacturing on which some coating is given, some coating on that, some on that material, some coating is to be has to be given for uh, long lasting, right? So in that case this chamber we have to keep in the chamber where continuously heat treatment, I mean uh, hot steam hot steam should be provided to here to this metal. So this chamber has to be monitored, or the temperature of this chamber is always should be monitored. Here sensor to monitor the temperatures, right? So in that area thermocouple is used. Thermocouple is used. So a thermocouple is used here. In the composite material constructions, we are using the thermocouple in this particular chamber where some coating has to be done. The material should be coated with some specific metal. In that case, a hot steam with in pressurized high pressure has to be always flow through this pipelines, right? And here that hot chamber temperature has to be monitored always. So to measure that temperatures, we are using which device? Thermocouple here. Okay. Thermocouple. Next applications are, this is a aeroplane landing wheel, right? Landing gear. Here also, while the aeroplane is landing, right? In that case, this landing gear is provided with a temperature monitoring instrument, right? Temperature monitoring instrument. In this temperature monitoring instrument, we are using the thermocouple, right? Because high amount of heat will be produced when the aeroplane will be land to the Earth's surface. So to monitor the temperature here, thermocouple also used. So these are the aerospace in the aerospace a very huge amount of applications we will get for this thermocouple. In the aerospace turbo engine, okay, turbine are used, turbine temperatures, that temperature monitor is done by this thermocouple, right? Monitor means measurement, continuous measurements is done. Exhaust gas from this aeroplane, exhaust gas side from the aeroplane also, that temperature also should be monitored always. That is also done by this thermocouple, right? Totally this aerospace full application of thermocouple you will find, right? And apart from that, industry sector, I told this one example in the case of composite material manufacturing. Okay, now what the devices we are using, in that devices we are using the thermocouple for temperature monitoring purpose. And here also, apart from this one, we are using for home appliances also this thermocouples, right? So these are the several applications of the thermocouple, and advantages, disadvantages, everything I told, basic principles, right? I hope. And here come to this last one. What are the several types of thermocouples are? This B, R, and S type, where platinum and rhodiums are used, right? Platinum and rhodiums are used, which is rarely used this type of thermocouples because these metals are not available in huge quantity, right? But the measurement of temperature range also in this case, you see, to 2500 to 3100 degree Fahrenheit, 1700 degrees Celsius, right? Here 1400 degrees Celsius, like this. Like this, we can measure, right? Here, another types E, J, K, N, and T is manufactured by this iron, nickel, chromium, tungsten, and aluminum, like this. The metal is not at all a problem to get in from the nature. So widely used. Basically, the K type, J type, these thermocouples are widely used. T types, right? T types for laboratory purpose, any laboratory instruments, any experiment, those we are using this T type, J type, K type, right? So this is all about the thermocouple explanations, descriptions, right? I hope you got a clear clarity on this thermocouple, right? So I will conclude here. In the next video, I will take one more new topic. I will in details I will discuss that, because this temperature measurement chapter, it is not over till now. It will take few times more. I think 2 to 3 videos we have to do on this one, right? So till then, you take care and bye.